Welcome back to Atomic Structure and Nuclear Chemistry. In this video, we will look at the structure of the atom in more detail. Please make sure to have your periodic table with you as you watch. You will need to refer to it as you take your notes. An atom is the smallest unit of an element that maintains the chemical properties of that element. During chemical reactions, the atom does not split. There are two regions of an atom that contain particles of matter. The rest is empty space. This table summarizes the properties of the three subatomic particles. As far as the masses are concerned, you do not need to memorize those masses, but what you need to understand is that a proton and a neutron have practically an identical mass, and also that the electron's mass is much smaller. In fact, an electron is about 2,000 times lighter than a proton or a neutron. Over here we have a Bohr model of an atom. Although we know that this model is not accurate, it is often a very useful model to represent the location and number of protons, neutrons, and electrons in an atom. Let's compare the masses of protons and electrons. If a proton were to be a rat, here we have a rat proton right here. What animal could an electron be to have a good analogy if we want to compare their mass? Pause the video and try to spot the electron animal on the slide. Okay, here it is. And it would be about the size of a flea. Let's continue our analogy. Now we want to compare the charge of our bigger proton and much smaller electron. The charge is exactly the same in magnitude. Both have a charge of 1.6 times 10 to the 19 coulombs. The only difference is that the electron has a negative charge, whereas the proton has a positive charge. Because the magnitude of the charge is identical for protons and electrons, when we assign charges to these particles, we use whole numbers. So for example, one electron will have a -1 charge, two electrons a -2 charge. One proton will have a +1 charge and two protons a +2 charge, and so on. Let's now compare the mass and volume of an atom. The nucleus, as we know, contains almost all of the mass of the atom, but the electron cloud is responsible for almost all of the volume. So if the positive particle below, over here, were the actual size of a proton in a hydrogen atom, it would take a screen about 1 mile across to display the electron cloud. Now have your periodic table handy. The periodic table is organized in order of increasing atomic number. What that means is if I read the periodic table from left to right like a book, and I start with hydrogen at number 1, hydrogen has an atomic number of 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, and so on. So the atomic number defines the element. On your periodic table, it is the number that is found on top of the element symbol. When you change that number, you switch element. So what does the atomic number represent? It is the number of protons in one atom of an element. Therefore, the atomic number or the number of protons will define an element. In a neutral atom, the number of protons and electrons is equal. So if we, for example, take carbon, which has an atomic number of 6, it means that carbon has 6 protons, and therefore the charge, because of the protons, will be +6. So carbon has to also have 6 electrons with a total negative charge of -6, so that the +6 and the -6 cancel each other, and we end up with a neutral atom with a charge of 0. Therefore, the atomic number is also equal to the number of electrons in the neutral atom. A useful acronym to remember that is APE, where A is the atomic number, P is the number of protons, and E is the number of electrons, and they all equal each other. Note that in an ion, electrons do not equal protons. We will talk about ions later in the video. The mass number is the sum of the protons and neutrons for a particular atom or isotope. We will define isotope in the next slide. It is the mass of the atom. Remember that electron mass is so small that it is considered negligible, so the mass number only takes into consideration the number of protons plus the number of neutrons. So again, if we have the carbon atom over here, and we know its atomic number is 6, it has 6 protons. And if this carbon isotope has 6 neutrons, the mass number will be 6 plus 6, and we will have a total mass of 12. A useful acronym for that is MEN. So mass number equal atomic number plus the number of neutrons. If we put our two acronyms together, we have the acronym MEN. Isotopes are two or more forms of the same element that differ only in the number of neutrons. Chemically, they react identically because we still have the same element. So for example, hydrogen has 3 different isotopes. We have the first hydrogen isotope with 1 proton and 0 neutrons, so a total mass of 1. Then we have deuterium with 1 proton and 1 neutron, so a total mass of 2. Finally, we have tritium with 1 proton and 2 neutrons, a total mass of 3. Note that the number of protons in all 3 isotopes stayed 1. It did not change. What changed was the number of neutrons from 0 to 1 to 2, and therefore that changed the mass from 1 to 2 to 3. So because isotopes of the same element have a different number of neutrons, they will also have a different mass or mass number. Isotope notation is a shorthand notation that allows us to identify an element when it is written in that shorthand form. So for example, if we have a bromine atom and we are told that the mass number of that isotope is 80, this can be written in several ways. You need to be familiar with all these isotope notations. So bromine 80, we write the full name of the element followed by the mass number. The second shorthand notation, we write the element symbol, which you can find on the periodic table. The mass number goes on top. And over here, that 35 is the atomic number. Where do we find the atomic number? We go to the periodic table, we find bromine, and it will be 35. A third way is to write the element symbol and only write the mass number on top and not the atomic number, because we can always find that information on the periodic table. And finally, the element symbol followed by the mass number. Here we are comparing what you see on your periodic table for a particular element and the shorthand notation for one isotope. So on your periodic table, the atomic number is on top of the element symbol. On the shorthand notation, it's at the bottom. Be careful about that. Then over here on your periodic table, we have what we call an average atomic mass. What this mass is the average mass for all the bromine isotopes that exist in the universe. On the shorthand notation, the mass which is on top is the mass of only that one particular isotope of bromine. Let's now practice, given a particular isotope or isotopes, how to calculate the number of protons, electrons, and neutrons in those isotopes. So if we have carbon as our example, we have 3 carbon isotopes over here. We can go to the periodic table and find the atomic number of carbon, and it will be 6. If carbon has an atomic number of 6, we can immediately say that it has 6 protons. And every isotope of carbon will have 6 protons because the atomic number defines the element carbon. If carbon has 6 protons, it also has to have 6 electrons. Now, to calculate the number of neutrons, we can use our APEMAN acronym, and since mass number is atomic number plus the number of neutrons, to calculate our neutrons, we can just take the mass of the isotope and subtract the number of protons, which is the same as the atomic number, and we get the neutrons. So then carbon 13 will be 13 minus 6, and we get 7. And finally, carbon 14 will be 14 minus 6, and that will be 8. Finally, let's talk about ions. Atoms form ions when electrons are lost or gained. The number of protons is not equal to the number of electrons anymore, and that results in an electrostatic charge, which could be positive or negative. When an atom gains electrons, it forms a negative ion, and that is called an anion. When an atom loses electrons, it forms a positive ion, which is called a cation. How you can remember that is the N in anion can stand for negative, and the T in cation can look like a plus, and that's the positive ion. Let's look at a couple of examples. The element magnesium forms a positive ion. So let's take a look at neutral magnesium over here. It has 12 protons and 12 electrons with an overall charge of 0. So we have our neutral atom. Magnesium forms a positive ion by losing 2 electrons. So it loses 2 electrons, and now we have still 12 protons, but 10 electrons only. So we have an overall positive charge of +2, and this is how we write the magnesium ion, Mg with a 2+. Fluorine forms an ion by gaining 1 electron. Here's our neutral fluorine atom. It has 9 protons and 9 electrons. Overall charge is 0, so neutral. Fluorine gains an electron. There it is over here, an extra electron. So now we have 9 protons and 10 electrons. So we have 1 extra electron with an overall charge of -1. And this is how we write our fluorine ion, F with the negative sign. Negative without a number implies a -1. It would be the same for a positive ion. Plus without a number would imply a 1. This concludes our video for today. I hope you have taken good notes. Come to class prepared with your questions.